Hi, I'm Emma, and I'm an educator at Great Lakes Aquarium. And today I want to show you a little science trick you can try at home. In front of me, I have a plastic bottle full of water, and inside of it is a little eyedropper. You can see its black cap floating right at the top. What I'm going to do is squeeze the bottle, and you can watch that eyedropper sink all the way to the bottom. When I release, it rises back up to the top. One more time. I squeeze, and it sinks. I release, and it rises. Now what's really happening when I squeeze this bottle is that I'm putting pressure on everything inside. Now there's no place for the water to go, the bottle is sealed, and you can't actually squish water any smaller than it already is. It's what we call a non-compressible fluid, but that's for another time. The only other thing inside this bottle that I can squish is the little bubble of air at the top of the eyedropper. When I squish the bottle, that air bubble gets smaller. Because it's the same amount of air, just taking up less space, it becomes more dense. We already know that anything more dense than water sinks in water, so all I have to do is squeeze hard enough to shrink the bubble just enough to make the diver dense enough to sink. When I release, the bubble goes back to taking up more space, making the diver less dense than water, and the whole thing floats back up to the surface. But don't take it from me. Next, you're going to make a Cartesian Diver of your own. The first thing you'll need is a plastic bottle. You want something with a little bit of squish to it. And you want to fill it all the way to the top with water. Next, I need a small eyedropper or pipette. And if you don't have one at home, that's okay. We can make our own using just a bendy straw. All I need to do is take a pair of scissors and trim it so that I have a nice little U shape. Now, I have two tasks. One, I want to make sure this U shape sticks together. I need to find a way to keep it from popping open into an L while it's underwater, because I need to make sure that it holds onto an air bubble the way that the eyedropper did. Next, I also need to figure out how to weigh down that diver so it floats at the surface, but just barely. I want it to almost sink, but not quite. You can use any kind of weight for that, but it won't take much. Just a couple of pop tabs, a couple of rubber bands, maybe a small coin will probably be just enough. You really just don't want to overweigh it so that the whole thing sinks before you get a chance to try the trick. Mine uses bobby pins. You can see that I stuck the bobby pins into the open ends of the straw so that it holds together the U shape and it weighs it down a little bit. Let's give it a try. You want to notice also that my water level goes up to the top of the bottle. Remember, I'm going to be using my squishing energy to compress the air bubble inside of the straw, and I don't want to waste that energy on an air bubble at the top of the bottle. I also want to make sure I am tightening this lid down all the way, because again, this only works if I push the water and it has nowhere else to go, like exploding out the top. Let's give it a try. And there it goes. It goes down to the bottom, and when I release, it pops back up to the top. Congratulations, we've made a Cartesian Diver. Now, if yours doesn't do that yet, and it only floats at the top, no matter how hard you squeeze, just add a little bit more weight. Or if it sinks all the way to the bottom before you even put the lid on, you need to take a little bit of weight off of the diver. Now I want to take a minute and look at how Cartesian divers are found in nature. Have you ever seen a fish float in the water without seeming to go anywhere up or down and not really seeming to put out any energy to do it? That's because fish have an organ that acts like a Cartesian diver. We call it a swim bladder, and it's a bubble of air that sits inside of the fish's body. When the air bubble is full, the fish floats up near the top. When the fish wants to sink, they dissolve some of that air out into the rest of their body, the bubble gets smaller, and they go down, just like our Cartesian divers. Now for an extra challenge, I want you to try with your diver to float. Just hover in the water column without going all the way to the top or all the way to the bottom. You might find it's a little harder than it looks. Who knew fish were such experts at Newtonian physics? But that's beside the point. The point is, the physics of density, pressure, and volume are everywhere in our lives, and it's the unique properties of water that make life possible on planet Earth. So, thank you for joining me for this science trick today, and from all of us at Great Lakes Aquarium, have a great day. Thank you. I'm going to drop it into my bottle to test it. No good. Now I have to fish it out. For mine, I used a hair tie, bobby pins, rubber band, 2 pop tabs, and a small screw. Let's test it. It also has to fit inside the bottle. We want it heavy enough that it won't rest all the way to the top. Oop, that's no good. Then, I want to make sure the whole thing is sealed really tightly. Ooh, I squished it a little bit. Let's drop it in. That's perfect. It wanted to sink, but not quite.